Hi everyone, we're going to evaluate a triple integral here. This is a multivariable calculus problem, and let's see where this takes us. We have this triple integral, and we're going to integrate the function 6xy, and E is the solid region over which we integrate, and I think that will possibly be the challenge, is trying to figure out how to sketch this solid region. So let's maybe, well, where should we start? Let's start with this plane z equals 1 plus x plus y, which is the same thing as x plus y minus z equals 1, negative 1. So I don't know if that really makes any difference to write it like that, but possibly. Okay. Or negative x minus y plus z equals 1, all right? So let's see how this goes, just this part right here. Okay, so one of the things we can do is to try to sketch this plane is to find the intercepts with the x, y, and z axis. So I think you can do this in your head, and how is that? Can you do this in your head? Well, okay, so here's x, y, and z. And so if I put, say, x0 and y0, if I have, whichever form I have here, x0, y0, we get z equals 1. If I put, say, z0 and y0, c0 and y0, I have x is equal to negative 1. And if I have x is 0 and z is 0, x0, z0 makes, well, maybe I'll do it up here. Same thing, right? x0, z0, y is equal to negative 1. Okay, so let's see. Okay, so first of all, this point up here is one of our points, 0, 0, 1. And then we have a point back here. I guess I'm not going to try to get exactly the scale. Or this is a perspective drawing. So we have that point, and then we have this other one, negative 1, 0, 0. So as far as drawing the picture, it's a little bit of, I don't know, it's all right. But so I don't know which octant number that would be, but maybe it's a third octant. I don't know. Okay. Now what we're going to do is we're going to look at the other conditions here. Y equals the square root of x. Okay, the thing about this picture, it's correct, but this is sort of implying that it's only sitting over here. So what's happening is this plane, and that's a totally legitimate way to draw it, but this plane is extending. It's an infinite plane, and it does not just lie over the region that I'm showing. And in fact, our graph is y equals the square root of x. And let me sketch that in the xy plane. So I would say that maybe the reason this could be that someone asked, how do you do this problem? It's just the sketch. And I have a feeling that I'm never going to be able to draw a really great sketch of this. I mean, maybe with a computer or something. But, okay, so here's y equals the square root of x. And that was one of our bounds also. And then we have y equals 0, which is, the x-axis. It's really extremely important that I label this x and y. Then we have x equals 1. So let's put that right here. So I sort of zoomed out, but I really want to zoom in here. So this is x equals 1, y equals 0. So, all right, so we have this little piece right here, and that's D. Okay, so that's D. And this plane, I sort of spent a lot of time doing that, and maybe redo the video without spending so much time on that. But anyway, here is D. And so we're looking at the region underneath that plane, And what we have is we have like a little house, and I'm gonna warn you, this picture is not gonna come out that well, but it's coming up like this, and it's bounded above by this, like this rooftop up here. Okay, so there's a roof, and so if you wanted to think about you're stepping inside that house, anyway, the roof is slanted, so it's by that red plane. I've drawn that plane only a certain way, only, you know, through the intercepts, but it extends infinitely. Okay, so what happens then is we have a house, I would say, that's why sometimes I think of it that way. The floor of that house is z equals 0, and the roof of that house is z equals 1 plus x plus y. Okay? And what are we trying to do, actually? So we're trying to, okay, we're going to integrate here. But let's go ahead and find out what, I was wondering if we were just doing volume. Okay, so we're looking at x, y, z, and what are the conditions? So z is bounded on the top by 1 plus x plus y, and on the bottom by 0. In this case, the floor is just the xy plane z equals 0. There are other homework problems where the floor is a different function. You have a function at the top, and you have a function on the bottom. Here we just have, well, you know, z equals 0 is a function. But you have to be careful about that. Okay, and then now you could do this, which is sort of seems like like I'm super, like, I don't know, lazy, or just I'm sort of kicking the can. I'm just going to say x, y belong to D and deal with D later. It's totally legitimate. The book does that. Why can't I do that? So I could at the same time figure out the bounds on D and so forth, but I'm just going to write that for now. All right, so our integral over E of 6xy dv is the integral over D, and then the integral in Z of, okay, 6xy dz, and Z goes between 0 and 1 plus x plus y. And then we have that, and then when we get that answer, we're going to integrate over D, which is why I'm writing dA, because that's a planar region, as I'm showing here. And by the way, while I'm here, why don't I just write down what D is? I don't want to imply that I'm afraid of it. It looks actually sort of simple. We have above here the function y equals the square root of x. So y is bound by the square root of x, and below y is 0. And then we have x goes between 0 and 1. That's describing this as a type 1 integral, but you might say, hold on, let's write this as a type 2 integral, and it might make it easier. We'll see when we get there, but you could write this squaring both sides, x equals y squared. We already have x equals 1, so you could write d equals xy such that x is between, problem is space here. But you could write, it might be easier to integrate, but not that much different anyway. But you could have xy such that x is between y squared on the left, so I'll put that below, and 1 on the top, and then y is between 0 and 1. So that's our D. You could write it either way. I hope you see. What you're not supposed to do is, okay, so you see this is 1 right there. You're not supposed to integrate 0 to 1, 0 to 1. The boundaries are functions. So be careful with that. Okay, let's go back to just this, what I have written down here. Okay, we're integrating with respect to z. If you notice then, 6xy are constants with respect to z, and we're just integrating 1 with respect to z. And that's 0 to 1 plus x plus y. When you integrate a constant, the result is just that constant 1 times the length of the interval, or the difference of these bounds. I mean, of course, you can just integrate 1 and get z, and then plug in the top bound and the bottom bound. Okay, so we have integral of d, 6xy, 1 plus x plus y dA. So You can integrate this type 1 or type 2. I just had this sort of notion that it might be easier to put in, but maybe not, whatever, to put in y squared instead of square root of x. So it's easier to integrate y squared than it is to integrate square root of x. So I think I might go with that. So I'm going to integrate that x is bounded between y squared and 1. I'm going to have to multiply this out also. I can bring the 6 in front, but the other things I'll have to multiply out. So I have xy times 1, xy times x, so I have x squared y plus xy squared. Okay, so this is dx between x equals y squared and x equals 1, and then dy, that's between 0 and 1. So first we integrate with respect to x. So you have to, yeah, we're going to integrate with respect to x. So I'll have 0 to 1, so I'll have x squared over 2y plus x to the third over 3y. By the way, if you wanted, you could group these. If you thought that might be easier. No. Okay, x squared over 2y squared, and that's going to be from y squared to 1, then dy. So, okay, let me just go ahead. I'm just going to put in 1 first. So I'll have x squared over 2 times 1 plus x cubed over 3 times 1 plus x squared over 2. Sorry, I'm doing it wrong. I know, I sort of lost concentration for some reason. Okay, I'm plugging in values for x. One of the ways that can help me not do that mistake is I can write for my bounds x equals y squared and x equals 1. See, you're welcome to do that here. So, because I sort of lost my concentration for whatever reason. Okay, 1 squared over 2y plus 1 to the third over 3y plus 1 squared over 2y squared. Then I subtract, now I put in y squared. So I have, I mean, this is totally doable, but it's a pain. It's just, I feel like I'm going to make a mistake, but just not, okay, just got to have confidence and all that. It's fun, though. Are you guys having fun? Yeah. Okay. All right, y squared over 2y squared. All right, so I would say that it might be worthwhile to slow down a little bit and just check it out. I mean, this part here, when I put in 1, I could have just, you know, putting 1 just gives, it's going to give y over 2, y over 3, y squared over 2, okay? And then it's almost sometimes I feel like if I do this in my head, I might even do better. All right, so, okay. So this is equal to 6, integral 0 to 1, y over 2 plus y over 3 plus y squared over 2 minus y squared times y makes y squared squared is y to the 4th times y makes y to the 5th over 2, and then at the same time I'm distributing the negative, minus y squared to the 3rd is y to the 6th times y is y to the 7 over 3, minus y squared squared is y to the 4th times y squared makes y to the 6 over 2 dy. So then I have 6. Okay. 1/2 times y squared over 2 plus 1/3 y squared over 2 plus 1/2 y to the 3rd over 3 minus 1/2 y to the 6 over 6 minus 1/3 y to the 8 over 8 minus 1/2 y to the 7 over 7. I'm just going to put in 0, 1. Putting in 0, everything's 0. Putting 1, all the y's become 1. So this is going to be 6, 1/2 times 1/2, 1/3 times 1/2, 1/2 times 1/3, minus 1/2 times 6, minus 1/3 times 8, minus 1/2 times 7. It's just going to be so satisfying if I get the right answer. It's going to be so awesome. Okay, so this is 6, 1/4 plus 1/6 plus 1/6 minus 1/12 minus 1/24 minus 1/14. That's the hard one, the common denominator is 7. All right. So, well, let me just do, maybe these will all simplify here. Well, maybe do 2 at a time. I don't know. Let me get a common denominator of 24 and leave the 14 all by itself. Or actually, maybe I should multiply the 6 throughout, but maybe I won't. Okay, so let's see. 6/24 plus 4/24 plus 4/24 minus 2/24 minus 1/24 minus 1/14. I guess I could have taken, from the 6, I could have taken a 2 and multiplied it through. That would have made the number smaller. So this is going to be 6. 6 plus 4 is 10, 14, 12, 11. Okay, let me take away a 2 here. Then I'll have 2/24 times 11 minus 2 times 1/14. I don't know, I'm not feeling super confident. Okay. All right, then, let's see, 12 times 7 is 98, isn't it? No, sorry, 84, right? So, okay, so our common denominator is 84. Well, I'll just write it like this. 12 times 7, 11 times 7, minus 12 times 7 times 12. So this is 377 minus 12, and then 84. And then, by the way, okay, is this correct? All right, anyway, let me just keep going on this. Okay, so this is 65 times 3/84, but 84 is 3 times, what?
3 times 20.
Awesome. So 65/28, is that the answer that we said?
Yes.
What? Isn't it just amazing that we got it? It's like, that's so crazy. Like, after all that, all those fractions, all that, and here it is over here. I wrote it down actually before the video started. The answer is in the corner. Oh my gosh. I feel like I could have done the fractions a little quicker some way, but anyway. Wow. All righty. Yeah, I probably should have multiplied the 6 or something from the very beginning, maybe. Yeah, that would have made it easier, maybe. Okay, well, so, and then the thing is, I have this picture. Let me try to draw just on the side. I mean, I think that this plane, the whole thing didn't work out well, the plane, but I think the picture is like this. Okay, so here's D, and then it goes up, and it's like, I mean, it's a little house where the roof is slanted. Well, the floor has a weird pattern too. Well, anyway, it's not that much different from what I have over there. But I mean, this whole thing, what I did with the plane in this case didn't really add, but you don't have to make the whole thing like that. You just cover up pieces and you get the intercepts and you get an idea for the plane, but for this picture, it didn't really come out that well. Okay, well, that's all. So like, comment, subscribe if you could. Thank you so much. Goodbye.